All right, go, folks, and we're live. We're recording. We're going to continue on chapter 14 with more discussion about inheritance. And you might, and I'm just kind of Googling this result as if I've done this, and knew exactly what I was gonna find. I did, but I didn't. Point is, I didn't know exactly what site I was gonna land on. So I'm Googling this, and my Google search, you might have noticed, is pillars of object-oriented programming. If you think of pillars, obviously they hold up. So what are like the four pillars of object-oriented programming? And this is something that you'll hear about. Basically, these are your foundations of OOP. And so if we're looking at the pillars of object-oriented programming, one, and if you don't know these by the end of the class, you should. So let's kind of, we introduced inheritance yesterday. And so now you're familiar with inheritance and how a class can inherit non-private members from a parent, a single parent. And once you understand a little bit about inheritance, then you can get into this fun word called polymorphism. So polymorphism is considered one of the four pillars. Encapsulation we've touched on, and we've done, and the idea of encapsulation is pretty simple, in that all of the I think of encapsulation. I grew up in the 90s, and they used to do time, like I'm trying to think of the word. I think it was on like Nickelodeon, and they would take all of the things of the 90s, like all the clothing of the 90s, all of the time capsule. And they would take all of the pop culture and all the memorabilia and the baseball cards and all the things that were kind of commonplace in the 90s, and they encapsulate it, if you will, into a time capsule. And then Nickelodeon, they buried it 100 foot deep, and they said, okay, in 50 years we're going to unbury this time capsule, and it's going to have all the things in it that represent the 90s. Something like that, and whether it was in space or in the ground, that's the idea. And so what is encapsulation? That's encapsulation, okay? Encapsulation is taking all of the things that represent something and putting it in one container. So what's our container? Well, our container is our class. In this metaphor, right, the container is the class. And what we're going to do is we're going to encapsulate all of the members that are relevant to that class in that capsule. Okay, that's all encapsulation is. It's just to say, hey, all of the important methods and all of the important attributes around a thing are going to be encapsulated into this class. That's all encapsulation is. And we haven't really got to the point where we can talk about abstraction yet. Point is, we're going to talk about this one today. All right, fun word, polymorphism. Yesterday we introduced one concept, which was inheritance. Encapsulation, you could say, well, we learned about encapsulation in the last chapter, where we learned about classes and objects, and we learned how to encapsulate members inside of a class. And we're going to get into polymorphism. So let's dive into polymorphism. So for this example, I'm going to kind of clear out the code that I had yesterday. Really, I didn't. Yesterday, just to keep things simple, I put everything inside of this constructor on Form 1. And I had all of these classes. I'm just going to close all these. We're not going to do that. We're just going to kind of do another simple inheritance demonstration, and for this demonstration, because inheritance, we learned yesterday, is defined or based on, inheritance is based on what things are. And so if I go with that concept, we're going to just go with a simple demonstration of, well, what are some things and that could inherit. So we might have a parent class called animal, and from animal you can already start to envision all sorts of child classes, all sorts of things that are animals. And what are the fields and what are the methods that we're going to encapsulate into this class, right? So, and you know, I'm just off of the cuff here. Animals probably have a number of legs, and you know, a snake, that number might be 0. You know, but animals probably have a number of legs. What about we just give it a name of the animal? That's an idea. You know, of course, if you get like the dog and you talk about the dog's name, like, okay, Rover, that kind of thing. But that doesn't mean that all animals, that doesn't make sense, right? Not all animals have legs. Like, I'm just thinking of like, species. Okay, so an animal has a species?
Or actually, would that be,
that's what,
would that be another class?
That would be another class. So like, yeah, I'm thinking that could be a classification.
It'd be like, yeah, a dog is like a German Shepherd.
Yeah.
You say age, maybe?
Okay, so let's go with age. I like age. Animals have an age, whether that's like in days or in hours or in years, whatever. I like that. Let's do it in age.
What would we consider, like, if it was an amphibian or like a mammal? Is that also an animal, or is that a separate
Family.
thing?
It's called family.
Family, yeah. So let's just keep it simple for this. Let's just presume, you know, and well, what can animals do? I'm going to make a method called move, and that's going to be part of my demonstration here. And so, you know, in the sense of move, I'm just going to have this return a string. And, you know, this is going to be the behavior when you call the move method. The generic animal, how does the generic animal move? You get to define this, right? You could just say the animal inches forward, you know, whatever. It goes forward an inch. How about that? How about goes forward an inch, it inches forward, however you want to say it. The point is, here's a generic method that if you were going to say, okay, how does an animal move, we could define it like such. And then we can have all of our, since these are going to be, these fields are going to be basically standard, I'm not going to have any sort of unique code, I'll make these auto-implemented properties, right? So number of legs and age. So I've kind of showed this before. You could take this and make this a property like such. Int number of legs. And so again, this is called an auto-implemented property. I think of auto-implemented, what does that mean? I think what that means to me is that the instance field is automatically created for you. So this is a property that automatically creates an instance field. In other words, you don't need when you do this, you don't need the private int number of legs. This part is no longer necessary. So auto-implemented properties, when you have very standard pieces of data, you could just use auto-implemented, and it becomes really fast. So we had a number of legs and we had int age. Okay, and these are just two properties and one method. And so our class has three members, right? The members are the two properties and the one method. The method says move. And great, so now we've got this animal class, and so underneath animal, let's have a child class, which, by the way, you know, I talked about parents and children yesterday. You'll also hear parent class and child class. You'll hear super class being the parent and subclass being the child. And I think there's another one. You know, all this language just basically representing parent and child. The derived class and the super class, that kind of thing. Let's add a new class. We have animal, so we got dog. And of course, dog inherits from animal. And what we learned yesterday was now when we create a dog, I've got things like my dog dot age, my dog dot number of legs, and I've got label result dot text equals my dog dot move. Move is a method that returns the animal inches forward, and that's what you would expect. We also learned about overriding, and so because a dog is a more specific animal, the dog might move differently than the animal does, right? So it's common in child classes to override the method in the parent class, because right now when we move our dog, it just says, you know, the dog it inches forward, right? So you might want to public override. Now you notice it does not give us the option to override move here. The reason it does not give us the option to override move is there's a keyword that if a method can be overridden, you can mark it as virtual. And so now that you've marked this method as virtual, it says, hey, our children can override this method, and we should now see we've got the move option. Okay, and so now we can override move. And now this is interesting. What is base to move? Base to move is the animal's move method, right? So you don't necessarily lose that implementation. You could say the animal inches forward plus, you know, whatever you want to say. This dog runs fast. You know, whatever it is. Now, this is going to say the animal inches forward plus the dog runs fast. And so when we look at the implementation of move now, it should say both of those things. Right? So just so you understand what this is, base.move is saying call the parent's move method. The parent is animal, the animal is just forward. Now, maybe you want to do that. Maybe you want to use both the parent's version along with something more specific. Okay, but in this case, you know, that doesn't really, like what I'm saying there doesn't really make sense. I would probably just say return, you know, I would return the dog runs fast. You know, and so when our dog moves, we get the dog runs fast. I don't really need a more generic the animal inches forward anymore. Yes?
So do you need that virtual to call the move method or override the move method?
Yeah, you needed this keyword virtual in order to override it in the child class. Without that keyword virtual, you, like check this out. So if I take that off, you get this error message. Dog.move cannot override animal move because it is not marked as virtual, abstract, or override. So those are three different keywords. They work slightly differently, but for the sake of this, what's nice about virtual is you still have, oops, I need to do this in, yeah, public, there we go, typo. Does that answer your question? Okay, so that's where we left off. So dog inherits from animal, it overrides the move method. And what that means is the dog class has a more specific implementation of what it means to move than animal. Now it is worth noting that animal is a class of its own, and we could create my animal is new animal, and animals also have move and they have their properties, and the point I'm making here is that this is still a class, okay, that you could in theory use to create an animal in your software if you chose to, okay? Sometimes though, sometimes parent classes, and this is kind of going to foreshadow a little bit, sometimes if you go up the hierarchy so much in the inheritance chain, sometimes things become so generic that there really is no real world implementation. Like, is there a real world implementation of animal? They're always more specific than that. You know, there are specific types of animals, right? So there's not just one thing called an animal and you can look at it and say that's what all animal is, you know. That's so you know, sometimes things become so generic they're no longer classes, but they are abstract classes. And if you marked a class as abstract, that means this thing is so generic, that you would never create an object of it in your software because it doesn't make sense. And you notice if I mark a class as abstract, another keyword that's really important. Now the whole purpose of this abstract class is for inheritance. Its only purpose is to be inherited from. Okay, so that's a big difference between, you know, regular classes and abstract classes. Getting back to move. We've got a dog. A dog's an animal. Of course, we could have another. Called cat. And cat is also an animal, so we can inherit from cat. And if we talk about how a cat moves, the cat just lies around. Right? Cats don't really. They're kind of not a cat person. They just kind of sit there. Okay, so now we have a cat. Cat defines how it moves. We have a dog. It defines how it moves. If I come over into our form, if I create a dog versus if I create a cat, and of course, your cat can have an age. Your cat can have a number of legs. And your cat can move. So now, as you would anticipate here, the cat just lays around. Okay. So we see that this probably works how you would anticipate. Still haven't talked about polymorphic behavior yet, so let's introduce this word. Polymorphism is a fun word that I believe the textbook would tell you comes from Latin, which means many forms. And so words in the English language have many forms. And so, you know, you can say, I play guitar. You can also say, I play video games. Well, playing guitar is a very different experience. It's a very different behavior than playing video games. And so the word play has many forms. When you play guitar, depending on what you're playing, the behavior is different. Does that make sense? So in the English language, and just in this example, and I'm tying this into object-oriented, based on the object you're playing, the action is different. Would everyone agree? Based on the object you're playing, the action is different. So the word play is polymorphic. It has many forms. You could probably see where this is going. Depending on the object that's moving, the move method can take on many forms. And so this is really interesting because one thing that we've been doing this whole time is data type on the left, data type on the right, and their data types match. Right? We've been learning that all class long. The data types have to match on the left and right. And that's been true up until now. Now today we're going to learn that actually it's not always the case that the data type on the left and the data type on the right has to match. We can actually do something quite crazy and do something like animal equals new cat.
Is there some kind of like?
And you're going, why would I do that? Why would I do this? So what I'm saying is what we're doing here is we're still creating a cat. We're just able to store it because cat is an animal. We're able to store it in an animal reference. And you're going, why? Why would I do that? And I'm going to get there. I'm going to show you. Okay? Early questions, yeah.
Is this different than like implicit, explicit casting? Like, is this a...
This is different than, yeah. This is, well, I guess you could say that implicitly casting is happening here because cat is, well, being stored as an animal. I don't know that this is actually doing any conversion because it is creating a cat. And it's just storing it as a reference to an animal. But what the rule of the thumb here is the parent is on the left and the child is on the right. Right? So that's how I remember it all the time. You have to have the parent on the left. In other words, you can't do the other way around. You can't say something like cat is new animal. This is the way it works. And again, why is this beneficial in our code? I'll show you in just a minute. Yeah.
So since you're putting the cat in like equal to animal or whatever, do you have to make a new class for it every time? Like if you wanted to do like a bird, would you have to still make a bird?
Yeah, you'd still have to make a bird class. That's right. So now let's just check this out. If I do say animal.move. Okay, so I just want to show you this. You know, now the question that is natural is, well, is it going to call the animal.move or is it going to call the cat.move? And you make your guess. But it does in fact call the cat. Okay, so we are still, it's creating a cat object. You're just able to store it in a parent reference variable. But it's still in fact a cat, and it still has the cat. Like, let's make a unique thing for cats. Like, let's make I want to make a unique property for cat. So what is a property for a cat that dogs don't have?
9 lives.
All right.
No,
Number of lives. 9 lives. Yeah. Okay. Who cares? Prop tab int number of lives. Is the idea is that you just can't kill the things because you just really want them? No, I'm just, that is a joke. If anyone's on the internet, you should know that I'm joking. I like cats. No, I don't. All right. Cats have a number of lives, so let's go back to my form here. And you'll notice, actually, you do not get access. So you get access to the move method because it was in an animal. But notice I've created this cat object, and because I've stored it in an animal, I do not get the specific properties that are unique to the cat, right? In order to do that, you would have to say cat, my cat is new cat. Okay, so just, as a rule of thumb here, when you store a child as a parent, you have access to the parent's properties and methods. You do not have access, even though you are creating a cat and storing it in an animal. That's just how it works. It's just how it works. I don't want to explain too many things. It is just because, but that's how it works. And so I just demonstrated. I do not have animal dot number of lives is what we created. Number of lives. So if I come over here, I've got number of legs, but I don't have number of lives. Right, where if I were to say cat, another cat is new cat, and then, or actually I have your cat, so I could still say your cat dot number of lives equals 9. Ryan?
So you demonstrated that animal.move still displays the cat's move.
That's right.
So what if you have like animal dog animal dog equals new dog, and you call the move, and because the dog's move is different.
Yeah, so let's do that. So now let's create another animal, and that's a dog, right? And now we call another animal.move. What would you guess? The dog runs fast. That's a good thing to demonstrate. Okay, so we got 2 animals. They store child. Okay, so why though? We haven't really talked about why. Well, we talk about writing methods as reusable. Like you want to write these methods that are reusable. And so here's back to our polymorphic. Check this out. So I just said I play guitar versus I play video games. Based on the object you're playing, the action is different. So I'm going to write a method, public, I'm going to come up with a more creative name. All right, let's just talk about this. So this method is a public method. This method, I'm just creating this in the form. I'm just creating this method in the form, right? And so this method accepts a parent object. And then in here, I'll just call animal.move. Okay. So the data type that is the parameter is the parent class. And here, I just call animal.move. So now I'm going to write the same note just a little bit differently. Based on the object that's passed into the method, the action being move, the action is different. So what we have here is we have animal.move. Like up until today, when you look at a line of code, you would expect that line of code to behave the same way every time. Today that changes. Today I can look at line 45 and I can say, well, animal.move will behave differently based on the animal that it's referring to, based on the object, right? So in the past, one line of code would behave the same way 1,000 out of 1,000 times. Now let's demonstrate this, because do something is a method that has a void return type. It accepts an animal. It actually, I can take my dog and I can take your cat and I can pass them into do something. Because do something accepts an animal, I can pass it a child reference. I can pass it a child of the animal class. So do something is a method that takes in an animal. So the acceptable data types are really all three. It can take in an animal, it can take in a dog, or it can take in a cat. Basically an animal or anything that inherits from animal. Okay, so again, this method can accept an animal, object, or any child of animal. Well, okay. Well, if I say do something, my dog. Okay, so let's follow the breadcrumbs here. So, okay, we don't need to see initialize. We don't need to see this. Okay. We create an instance of the dog class called my dog. My dog has an age and a number of legs, which are default 0. We create a cat. We call do something, passing it my dog. Notice when I hover, look at this. When I hover the animal, you can see the animal references a dog. Demo. Do you see where it says demo1.dog? Animal holds a dog. And because now when I say animal.move, the move method behaves differently based on the object that it references. Well, it references a dog. So where does it go? It goes to the dog class and it returns the dog runs fast. So now I've written this method that can accept dogs and cats. I don't have to write different methods to accept dogs and cats. I can write one method that accepts dogs, cats, snakes, you know, etc., etc. And because of polymorphism, I can get different behaviors. And it all works. So let me run this without debugging. What did I not do? Notice animal.moved called dog.move, but I didn't actually put that into a label. So like maybe I would say label result.text equals animal.move. I got the dog to do something, but I didn't store it in a label. So now I store it in a label, and I see the dog runs fast. Whereas I can also pass it your cat, and you get that behavior. So what is polymorphism allowing? It allows us to write methods in such a way to accept all types of objects based on inheritance. And you get that generic method. Like, you don't have to write 30 versions of this method. You know, you should just write it once. And so it helps us from an efficiency standpoint. You don't have to write do something that takes in a dog and another do something that takes in a cat. One method that takes in. And I want to point this out. Yesterday, we learned about some common methods to override. Public override equals. This might make a little bit more sense now. Remember that the object class is at the top of the inheritance chain. So literally anything you can pass into object, because everything inherits from object. And so this particular equals method, like if you're thinking about, okay, we're going to write an equals method to determine if two animals are equal. How do you write that? Well, you're going to have to make this so that it can accept any kind of thing, because obviously sometimes the animals will be equal. You have two different animals. If you got an animal and a student, then they're not equal. And so this method should be able to take in a student. Well, how do you write a method that takes in a student? We don't even have a student class. Well, we do have a student class, but what about something we don't even have yet? Right? Or you don't even know about. So this method is written in such a way that it can take in any object. It's so generic that it can take in any object. And what I did yesterday, the first thing I did yesterday was I said, I tried to convert, this is a casting object as an animal, right? And if that cast works, then, you're already on, at least you have the right type. At least you have the right type. You might not do this cast immediately, because if you are trying to cast a student into an animal, that this line would crash and your program would not crash. You want to check the types first, yeah.
So is that a widening conversion or a narrowing conversion?
Yeah, that's a widening conversion. So you could think of it as a widening conversion because it's going up, right? It's going more generic. Well, when you send it into the method widening, when you cast it down, this would be a downcast,
okay,
so to speak, and when you send it in, it would be an upcast.
Mm-hmm.
Yeah.
What is that syntax error you're getting on equals?
Oh, what is the syntax? Well, at the end of the day, this method has to return true or false.
Oh, okay.
That's all that's saying.
It's bool.
Yeah, you're going to have some sort of if statement. If this condition is true, then return true. You're going to have to test to see if the animals are equal. By the way, I'm going to pause just a millisecond. I did make a comment that's saying, hey, if you just do this cast and OBJ is not an animal, that this in fact would crash and so you might not want that. And so you might wonder, well, how do I test to see before I do the cast? In other words, it's kind of like the try parse. You want to see if you can convert it before you convert it. And there's a type class that you can use that has let's see, obj dot. So there's let's do this. If I just want to demonstrate this, if obj, that's our generic object, get type double equals, and get type is a method. If obj.getType double equals type of animal, then we can do the cast. So get type, I demonstrated that yesterday. Get type returns, the class, the type that it is, double equals, and then there's a type of method, animal. And so get type, this get type, the type class, gives us access to the get type method. So if I'm thinking of this method, the first thing you want to do is convert it, right? But if the types aren't even the same, well then of course, then they're not equal. I'm going to return false here. And then now if I do convert this animal, I don't need to really flush this out, but now that I can tell that they are the same type, let's go ahead and cast it. And then you can say if animal, if this dot you would say if this number of legs equals animal dot number of legs. This makes no real sense, because are two animals equal if they have the same number of legs? No. This condition right here is how you determine if these things are equal. How do you determine if animals are equal? Again, this is just not part of the class. It's not really important, right? But this is what an equals method would look like, right? Number one, see if they're the same type. If they are the same type, convert it, and then run your condition to see if they're equal, and if they are equal, return true. You know, and you just code this out if they're and then I think you should be able to return that. All the way through the maze, you can return true or false. That's polymorphism at its most basic level. And so if you can understand, I think, you know, inheritance, if you can understand overriding and how a dog would move differently than a cat, that's, you know, overriding, then you can understand, let's write one generic method that can take in any animal class, and then based on that animal, you know, this move, the move is the behavior, and it would perform a different function based on the object that it's referencing. That's how it's worded in the book. Based on the object that animal is referencing, the action is different. And that is a polymorphic example. And so when you go to an interview and they say, hey, you know, we got these, I hear you understand object-oriented, and you know, one of the pillars, can you talk to the pillars of object-oriented programming? You're going to say, yeah, inheritance, and you know, it works like this, and polymorphism is the idea that a method behaves differently based on the object that it's referencing. And if you can understand that, you passed that check mark. All right. That was the main thing I wanted to cover today. Let me see if there's anything else that I find. Check this out. So if I take the word virtual off of here, this is the error message that we got. Ryan, we looked at this before. It says the dog cannot override move because it's not marked virtual, abstract, or override. I demonstrated when I marked it as virtual, I still had access to base. Right? So when I mark it as virtual, you still have access to the parent's version, or you would say the parent's implementation. Now let's see what happens. The other options, again, so virtual's most of the time what you mark it as, but there are some other options to mark your methods as, for example, override. So let's mark this. Instead of virtual in the parent, let's mark it as override in the. Well, that makes sense because it's saying, well, we know what override is. Override is saying, hey, we're overriding something in the parent. So you can't override move because there is no move in the parent. You know. By the way, what is the parent of animal? Animal's parent is implicitly object, right? This is an implicit thing. You don't have to code this. It happens automatically. So what about, again, so we know we're not marking it as override. The other option, though, is abstract. Let's see if I mark this method as abstract. Okay. Abstract is another keyword, and we're moving towards this. Notice when you have a method marked as abstract, an abstract method means it doesn't really make sense. The animal inches forward. You don't know how a generic, there is no generic animal. So how would an animal move? It doesn't really make sense to give this. This method is so generic, so abstract, it doesn't really make sense to define it. The whole reason that we want this method here is so that our children can exhibit that polymorphic behavior. So what we do here, when a method is abstract, we do not give it a method body. And it actually looks something like and by the way, it also has to be an abstract class. Okay, so what does an abstract class mean? Again, I'm actually hitting some important topics here. What is an abstract class? We talked about an abstract class briefly. An abstract class means you can't create an instance of it. So that gets rid of that. We can still inherit from an abstract class. That's the whole point. Dog can inherit from abstract class. But an abstract method is then, this animal class is so generic that we know that the children are going to move. We know that all animals can move somehow. But it doesn't really make sense to give a method body here because you're never going to have a generic animal move. So again, some notes on this. Abstract classes cannot be instantiated. If I spelled that right. Okay, you cannot create an instance from an abstract class. Abstract methods do not have a method body because they are so generic, it doesn't make sense to. And so the whole purpose of defining this move method and marking this class abstract is so that, hey, these classes can inherit, and check this out. Now watch this. If I inherit from animal, an animal has an abstract method. Look at this. Abstract methods actually require you to implement that behavior in a child. So because animal has an abstract method, we are forced to override the move method inside of cat. And you can actually show potential. And so now you could see that we override the move method, and well, this basically says we need to put in what a cat does. So it's like, hey, I'm going to make this abstract class. It's going to have some abstract methods. I know that when a child inherits from this parent, it enforces a behavior. You know, and I know for my video game folks, you know, I played League of Legends for a while, and you guys kind of have trolled me about that, you young kids, right? So what was League of Legends? League of Legends was a video game, and every champion had abilities, and there were 4 or 5 abilities, and I believe, it's been a while, but I believe they were Q, W, E, and R. Right? So in that sense, now notice dog is barking at me. Because you cannot, because base.move, there is no base.move. It's abstract now. So you cannot call base.move on an abstract method, right? So you can't do that. I just wanted to show, when you mark it as virtual, there is an implementation of the body. When you mark it as abstract, there's not. So you cannot.
Even if you're adding to it and you're not just keeping.
Well, keep in mind there's nothing to add to. It's empty.
Oh, it's empty. Okay.
It's empty. So you are completely defining what it is for the first time here. So in my League of Leg example, there is no generic champion, right? There are specific champions. And so I might have a class called champion. And that class, there is no, you cannot create a generic champion. They're all specific names of champions. And so, you know, our champions have names, right? But our champions also have abilities. Called, you know, execute a Q ability. Now, I would mark this abstract. So I marked the class as abstract because you'll never in League of Legends have a generic thing called a champion. You always have specific champions. And by marking this method as abstract, what this does is that any of my actual champions that I create, this enforces that there's a Q ability. All of my champions have to have a Q ability, right? I'll have another method, execute W ability, public abstract string E ability, public abstract string execute R ability. So what am I doing here? I'm making a template, by the way, a class, you know, is a blueprint. So I'm making kind of a template, a blueprint for a champion. But I'm not saying what any of these things are. All I'm saying here is that when I do create my first champion in my video game, I'll say add a new class and see if I can spell his name right. I played the jungler Hecarim. Boy, that's butchered. Hecarim, League of Legends, Hecarim. No, it's not. Hecarim. Okay, this is an actual champion. So there's, in League of Legends, there's a champion called Hecarim, and I would say inherits from champion. Hecarim is a champion. You with me? Well then, what is it going to make me do? It's going to force me to have these methods, right? Because I marked all of those classes as abstract. I can implement all of these methods now. By the way, this is just saying, all this line 13 is saying is that you haven't implemented this method. You need to implement this method and define what it is. And so return his E ability, which is, I don't know, AoE damage, whatever. How generic can you get? So going back to this, why do we mark a method as abstract? Is to basically, you're signing a contract when you inherit from this parent to say, I will implement these methods in this child. Yeah.
Can you go back to the champion class? Okay, why do you need the whole, like the class on line 9 as abstract and then also the methods as abstract?
Yeah. So what line 9 does is that it says that, like, in our actual game we cannot create a generic champion. Like, that doesn't work.
It needs to be a child of the, or it needs to be a parent of like another champion.
That's the whole reason this exists now, is to be a parent. You cannot create one of these things. You could only inherit from it. The reason this is marked as abstract is to enforce that its children do implement the method.
Mm. Yeah, I get that.
And you'll notice here, this came earlier, you cannot have an abstract method without the class being abstract. So it's actually a rule that if you do have an abstract method, it must be in an abstract class. Yes, sir.
And does this also work for for properties?
Great question. Yes, it does. So let's mark a property. You can have abstract properties as well. Now, I will say kind of the same deal. So virtual versus abstract. Abstract just means there's no. What you'll notice here is if I actually go to put in the method body, because it's marked as abstract, this should bark at us. And you're going to see here, you can't do this because it's marked as abstract. So you cannot have specific implementations of a property when it's marked as abstract. So very similar to the methods. That's a great question. All right. We're going to pause and take a break.